this video, we'll see how to prove that root 5 is an irrational number. This was asked in 2009. Series details have been provided for your reference. It's a 3-mark question. The approach is similar to how we proved the irrationality of root 2 and root 3 in our previous videos. The method used here is called proof by contradiction. In proof by contradiction, we start with the assumption that the statement opposite to the statement to be proved as true. The statement to be proved here is root 5 is an irrational number, so we'll assume the opposite, that is, root 5 is rational. Let's assume that root 5 is rational. All rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. These fractions can be reduced to their simplest form by cancelling out all common factors, and such a fraction will have its numerator and denominator as co-prime, or the numerator and denominator will not have any common factors. So let's express root 5 as a fraction of co-primes a and b, where b not equal to 0. So we've expressed root 5 as a fraction of co-primes a and b, and therefore a and b do not have any common factors. Now let's take b to the other side. We get b root 5 is equal to a. Now let's square both sides. So we get 5b square is equal to a square by squaring both sides. And this is our equation 1. 5b square equal to a square means 5 multiplied by some number is equal to a square, which means that 5 is a factor of a square. Therefore, 5 is a factor of a square. If 5 is a factor of a square, it implies that 5 is a factor of a. This is from a theorem that we studied in this chapter. If a prime number divides a square, then it also divides a. So this becomes our statement 2. Since 5 is a factor of a, there should be a number c such that a equal to 5c. Now let's substitute this value of a in 1. So substituting in equation 1, what is equation 1? 5b square equal to a square, which now becomes 5b square equal to 5c the whole square, which is equal to 5b square is equal to 25c square. Cancelling 5 here, we get b square equal to 5c square. So b square equal to 5 into some number. Therefore, 5 is a factor of b square. If 5 is a factor of b square, 5 is also a factor of b. And this is from the same theorem. If a prime number divides a square, it also divides a. So this becomes our statement 3. From statement 2 we have 5 is a factor of a, and from statement 3 we have 5 is a factor of b, which means 5 is a factor of both a and b, or 5 is a common factor of a and b. Therefore, from 2 and 3, 5 is a common factor of a and b. But we assumed initially that a and b are co-prime, which means they cannot have any common factors. So we've arrived at a contradiction here. So this is a contradiction to a and b are co-prime. This contradiction has emerged from our incorrect assumption that a and b are co-prime. So this is due to are incorrect assumption, which means A and B are not co-prime. Therefore, we've proved that root 5 is not rational, or root 5 is an irrational number. So the method used here is called proof by contradiction. In proof by contradiction, we start with the assumption that the statement opposite to the statement to be proved as true. The statement to be proved here is root 5 is an irrational number. So we assume the opposite, that is root 5 is rational. Rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. When p by q is reduced to its simplest form, it becomes a fraction of co-primes. So here we've expressed root 5 as a fraction of co-primes a and b, where b not equal to 0. Taking b to the left hand side, we get b root 5 is equal to a. Squaring both sides, we get 5b square is equal to a square, which becomes our statement 1. Therefore, 5 is a factor of a square, which also implies that 5 is a factor of a. This becomes our statement 2. If 5 is a factor of a, there has to be a number c such that a equal to 5c. So we substitute this value in 1, we get 5b square equal to 5c the whole square, which becomes 5b square equal to 25c square. Cancelling 5, we get b square equal to 5c square. From this, 5 is a factor of b square, which also implies that 5 is a factor of b. This becomes our statement 3. So from 2 and 3, we get 5 as a common factor of both a and b, which contradicts our assumption that a and b are co-prime. Therefore, root 5 cannot be expressed as a fraction of co-primes. Therefore, root 5 is not rational, or root 5 is an irrational number.